So I realize that board's a little smaller, but this isn't connected. So I'll just go the old-fashioned way. So I wanted to make sure we go through our review. Make sure you write down anything on this that would help you on our quiz that we will have tomorrow. This talks about this dyslexia. I am on page 139. 139. I think it's 139.
Yeah, 139.
Okay. So this talks about dyslexia, yes or no, left or right-handed. It gives us totals. So conduct a chi-square test to see if there's any association. So our hypothesis, dyslexia and handedness are not associated. So dyslexia and handed are not associated. Where our alternative is dyslexia and hand are associated. Okay, that should be pretty simple. So then we're going to kind of fill out our chart. We have yes, we have no, based on dyslexia. We have left, and we have right. Okay, so remember how we're going to fill this out. It's going to be, it'll be observed, expected, and chi-squared. All right, so I'm going to write the numbers that I got, and then if you have questions on how I got these, let me know. 8.8, 0.8, and 1.32. And then right-handed, we have 60, 68.8, 1.13, and 370, 361.2, and 0.21. Okay, so do you understand how the very first one, the 2050, the 60, the 370 were gotten with the observed? If not, how do we do it?
The expected value?
So the very first value. So how did I get, I just want to make sure you feel okay about these values. Yeah, that came right from the chart. So yellow comes right from the chart. Okay, you have to look up to it and just basically copy it down. Then let's see, are we okay with how we found each of these? The second number.
No.
Is that no?
Yes. No.
Okay, so that's expected value, right?
Yes.
So the expected, so the blue we'll do up here. And I'm sorry, I got to color it all in because it looks better that way. All right, so the expected value is the row total times the column total divided by the total. Okay, so if you looked at so the example of how they got, I'll do this first one, how they got that 11.2 is they did a row total, which was 80, times a column total, which was 70, divided by the entire total. So this is how they would have gotten this for the expected value. Okay? Does that make sense? How to get blue? Hello. I'm going old school. I got the smartboard going. But that one's just being silly. Yeah. So whatever you want to do, let me know. And then the last one, let's make sure we know how to get this one. We have green. How do we get this? The chi-squared.
Is that 0.21?
0.21, yeah. How do we get that one?
Observe minus expected over
Yeah. So yeah, observed minus expected, quantity squared over the expected. So let's do this one. Okay, we'll do this one so we can see an example of it. So they told us the observed in that place up there would have been 60 minus the expected. The expected there was the 68.8 quantity squared. So we're getting all that information from here and divided by the expected. So if we do that math, it's going to give us the 1.13. Okay? So is everything okay with up there? Did you follow my logic, my thoughts? Do you definitely see a problem like this tomorrow? Is there anything I need to add to it? We're not quite done with it yet. And this is obviously being recorded if you wanted that as well.
The green.
The green, yes.
The green is like x squared equals observed minus expected divided by expected.
Yeah, so it's yellow minus blue, square whatever that comes out to, divided by the blue. And so it'll be different for each one, unless you have the exact same numbers.
Oh, wait, is that for green?
Yeah.
Yeah, for the green.
So is the 60 minus 68?
Yeah, that would be for the green. Here, I'll highlight
it.
that. I'll highlight that in green. Just,
all right.
okay, well, I'll highlight it. Just make sure we feel good about it. Highlighter green. So that's that,
I already know that.
which is that. Seem okay? So it's all color coded. All right. So then they want us to go and find. They want us to go and find the chi-squared, which means I total all the green, add it up. So 6.91 plus 1.32 plus 1.13 plus 1.21. If I add all that up, I get 9.57. Okay. And then I'm going to do chi-squared CDF, which you'll be able to find on the calculator. So that's 9.57. Huge number. Okay. And then our degrees of freedom. Ooh. So we have to remember how to find the degrees of freedom. So because it's two things, it's row minus 1, column minus 1.
Wait, is it 1.21 or 0.20?
Oh, it's 0.21. Thank you.
No.
I looked at my slash and 0.21. All right, so degrees of freedom. I have two rows. I have two columns. 2 minus 1. 2 minus 1 is 1. 1 times 1 is 1. And this would come out to roughly 0.00198. I don't think they gave us an alpha. Anything like that? What?
So how do you find out, how do you find freedom for like
Degrees of freedom. I had left-handed, right-handed, so there's 2. I have dyslexia or not, there's 2. So 2 minus 1, 2 minus 1. It's whatever the rows minus 1 would be times the number of columns minus 1.
Oh, it's just 1 times 1.
Yeah, because we had left versus right, so 2 minus 1 is 1. Yes versus no, which is 2 minus 1, so that's 1 times 1.
So it's the number of rows and columns, not like the actual.
Right, it's what your data is. It doesn't include the totals. So if you looked at the dyslexia, you had yes, left, right, total. So some people might think it's 4. I'm looking on the worksheet.
Okay.
Okay, but you have left versus right because you're comparing left versus right. You're comparing yes versus no.
So it's just 1.
So yeah, it's 2 minus 1, 2 minus 1. Okay, so 0.098. So remember, we're basing this on a p-value being greater than 0.05. That's far less. Okay, so that's less. So what do? If it's less, we reject the null. Okay? And if we get to that point, we're totally fine. Okay? So we could say we find strong evidence that dyslexia is associated with handedness. Am I really looking for that? If we can get to the point that we realize we either fail to accept the null or we reject the null, I'm totally happy with it. So remember the p-value 0.05, unless they tell us an alpha score or a p-score, which will be the same. 0.05 is the kind of the universal cutoff. Okay, unless they told you differently. Like if they said, hey, you have an alpha of this, or you have a p-value of this, then we just revert back to 0.05.
So, you reject the null when p-value is smaller?
Yep. If that p-value was, say, 0.198, which would be bigger, we would fail to accept. Or fail to reject, excuse me, fail to reject. Sorry.
So, on the test, are you going to give us an alpha, or are we just going to have to assume?
I don't recall off the top of my head. If I do, I will point it out to you.
Great. Thank you.
I glanced at the quiz quickly this morning, and I can't remember if it's on there or not.
Okay.
All right, so that's the first problem. Any questions about that? All right, so let's flip the page over. All right. So, is there a difference of different age groups regarding flavor of ice cream they enjoy most? Random sample shows these counts. So they're doing age 18 to 30, 31 to 50, 51 plus. I guess they're not too worried about children. We have vanilla, chocolate, and strawberry. Certain totals there. Okay. Kind of a silly data table, but hey, we'll go with it. So I'm just going to reduplicate because we forgot to put the things. So we have age, 18 to 30. This is given to you. And you have vanilla, 20, chocolate, 30, strawberry, 20. And then you have a total. And then 31 to 50, 30, 20, 10, and then I have a total over here of 60. And then the old folks, that's me, 51.
What's your favorite syrup?
Ice cream. I love ice cream.
It's all of them. Like,
Yeah.
not favorite flavors?
Yeah, me and Baskin Robbins, I just get a scoop of each.
Okay. All 31?
Yep. Except for the sherbet, you know.
Sherbet?
Well, you know, when you have ice cream versus sherbet, I'm like, hey.
Yeah, that's fair.
So we should ditch your other classes on Friday the 13th, and then we can go get ice cream.
Yeah.
Full class.
All right, so this is the grand total. Okay, so I just filled that out because I didn't give you the totals. Okay, so our null hypothesis would be favorite ice cream is distributed for the same. Favorite ice cream is the same for age groups, for all ages. Alternative is favorite ice cream
So, Star,
is not the same. Yeah.
when it says a test of homogeneity, or however you say it, doesn't that have to do with the distribution?
Yes.
Okay, so then would the null and alternate be like the distribution of ice cream flavors over the ages is the same or different? Is that does that make, is that correct? Does that make sense?
So I want my favorite is, so I want the null is the same. What do you think? Oh, wait, you got there. Hang on, let's see if I can get there.
refreshing it multiple times just to see if it got caught on.
Let's see if we can get this. 915. I still got a panel ID. 915376.
Has this been locked?
What's that?
If you go to share.mypermission.com, is that where you're at?
It's just there. Oh, you just unplug it. It's okay. It's fully charged.
Let's bring up the browser window. Let's see if we can see if something changed. Just
Open up Firefox.
yeah. I'll just do it real quick. Go to share.mypromethean.com.
Share. Dot.
Yeah. It's just the bottom corner here.
Share.mypromethean.
Yeah, it's just really strange.
Promethean. METHEAN.com. Are we downloading?
Yeah.
That complete, so that means I can open it.
Yeah, or double clicking. Unless they had a software update or something.
Okay, so I'm gonna close this one because we don't need that anymore.
Yeah.
Go here.
How can we close that?
Screen.
Yes.
Yes.
See what it does.
Accept.
Oh, yeah, you got
And install.
Yeah.
It's unnecessary reinstalling, but that's okay.
Okay, so that means it's ready to go. Done.
And then we can close this browser window. See if we can get it to connect again.
So it's right here.
Okay.
915 376. Oops. 915 376. Oh, said it again. Panel ID. Just waiting room.
Let's just enable.
Oh, that just allows me to use the touch screen. So if I go there, it's still.
If you're at our waiting room, can you even get into it?
Uh-uh.
Oh, there's something going on with your Service Pro. Because I can keep refreshing this and it seems to work okay.
Huh.
I'll have to.
You see how many I know we're in the dark.
Yeah,
Yeah, it's still continuing to give me the error and the ID. Let me pause that. It's recording. All right. So, favorite ice cream. We have our null. So, distribution is the same for all. All right. So, let's figure out our expected. Calculate the expected value for the 18 to 30 group who prefers vanilla. Explain what this means. So the 18 to 30. So we had row total times column total over the total. So row total. Let's see. We had 70. Column total 90 over the 190.
Hold on, sir, how did you get 190?
That was my total.
Yeah, so, but why don't you have to add like the age totals as well?
We did. If you add those, so this coming down here should be the same as this coming across
So
here.
it's 70 plus 60 plus 60 plus 90 90 plus 60 plus 40?
No, I either went 90 plus 60 plus 40 to get to 190, or I went 70 plus 60 plus 60.
Okay.
All right, so this is going to give me 33.16. So what does this mean in the content? If the favorite flavor is unrelated to age, we'd expect 33.1%. 36. We would expect 33.16% of the sample to be in the 1830 that preferred to vanilla. So 18 to 30 prefer vanilla. This value here is what would be expected here. Okay? Calculate the chi-squared for the 18 to 30 prefer vanilla ice cream. Okay, so the chi-squared of that is, how do we get the chi-squared? Observed minus expected, quantity squared, right? Over expected. So observed would have been 20 minus 33.16, quantity squared, over the 33.16. So this is going to give me 5.22. And let's not worry about explaining that one. That's what our chi-squared is in that situation. Okay? The chi-squared test for this data is approximately 20.1, so they already have going through it for us. They've already told us what the answer is rather than going through it. Calculate the p-value showing your calculator commands. So problem number 4, we're going to go chi-squared CDF. They gave us the 20.1. This was given as part of the problem. This has to be a huge number. And then our degrees of freedom. I have 3 times 3 rows minus 1. 3 columns minus 1. 2 times 2 is 4. So my degrees of freedom is 4. And this is going to give me a p-value of 0.12377. Okay. So did they give us anything to go off that? Nope. So we know that p is greater than 0.05. This is way less than it. We reject the null. And the thing to remember is this value here, unless it's given, is there. Don't worry about the type of error. I'm not too stressed about that. But friends, if you can go through, if this was a good enough review for you and you have everything written down on that sheet of paper that you need, and I provide you calculators at work, you should do well. But that's all I have for you today.
How did you find the degrees of freedom?
Okay, so you had vanilla, chocolate, strawberry. So you had 3 things. 3 minus 1 is 2. And you had 3 age groups. 3 minus 1 is 2. 2 times 2. Mm-hmm.
Thank you.
Yep.